In this video, I'm going to show you how you can configure link aggregation on OcNOS switches. But before doing this, I'm going to make a few points which are very important before continuing. So let's just open this whiteboard and I'm going to drive some things for you. Let's say that there are two switches in my network. This is going to be switch 1. And there is another one here, switch 2, and these two switches are connected using multiple links to each other. Normally you would say that, okay, I have two switches, and if I want to connect these two to each other, I'm going to use one of the uplink ports, or maybe some of the normal ports. The uplink port, of course, is a high-speed port, and that's going to help me to have higher bandwidth. But if I do not have enough uplink ports, then what I'm going to do is to use two or more ordinary ports, and I'm going to just make sure that these two are going to work as a bundle. They are going to appear as just one link to spanning tree. Both of them are going to be utilized, and I'm going to have higher bandwidth when I do this. There are a few things that I need to show you before continuing this kind of configuration. And one of the most important ones is when we just bundle this, spanning tree is going to assume that this is just one interface. Let's say, for example, this is a port channel, for example, port channel number 1, or in case this is a static port channel, then that's going to be something like SA number 1, one of these two. But assuming that these two are channeled to each other, are added to an Ether channel, I just prefer to call it port channel interface. In case I am not bundling this, what is happening is spanning tree is going to block one of the interfaces on one side, and one of them is going to be in forwarding mode, and of course the other side is going to have interfaces as forwarding mode, but you know that this one is going to not going to be used because the other end is not in forwarding mode. This means that one of the links is going to be completely useless. If I have multiple links, again the same thing is going to happen. Only one of the links is going to be used, and in my case, for example, this is the bottom link, and the other links, whatever the number is, they are not going to be used because they are blocked by spanning tree. But when I bundle these interfaces to each other, what the spanning tree sees is just this one interface, that's it, port channel. And that's going to put loads, or let's say flows, are going to be transferred using these links to the other side. The other thing is, when I use these links to each other, when I bundle these links to each other, although I have one logical port, which I call it port channel or static port channel, what is happening is, as a matter of fact, each flow is going to use only one link. I cannot really use two links to send one flow. Yes, I have increased the bandwidth, but what I have received is this. I have a highway. What I have in this highway is I have multiple lanes here. A car cannot use all of these 3 lanes, and the maximum speed in this highway is not being increased, it's not increasing. Let's say that, for example, the maximum speed is going to be 75 miles per hour. You cannot really increase the maximum speed in this highway. What is happening is, instead of just one car at the same time, 3 cars can go through this highway. The exact thing is happening here. I can have 2 flows at the same time because I have 2 links here. I cannot use both links for one flow. And whenever I have a flow, and what is a flow, by the way, you know that source and destination IP address, source and destination MAC address, and the protocol, whatever protocol number is or port number is, so I just call it protocol. These are going to determine a flow. So a flow for all the packets has the same IP for source and destination, the same MAC address for source and destination, and the same protocol. If one of these changes, there is a new flow here. Now, based on this information, what we are going to have is a hash. This hash is something like an 8-byte I'm not sure, I guess, let's say for example 8-byte value, a hexadecimal value, and based on that we are going to decide this link or this link is going to be used to carry this flow. Whatever you do, whatever, even if a bit changes in these information, the hash value is going to be different and we are going to use another one. So based on this, now you know that although we have higher bandwidth, we cannot have higher speed, and we cannot have let's say one flow over multiple links. So this means that sometimes one of the links is going to be utilized more than the other based on the flows that we send on that link, and this is inevitable. So I wouldn't say, for example, 200 gigabit per second is going to give you a 200 megabit per second. That's going to be something like 100, maybe 50 megabit per second, or 180 megabits per second. In case, for example, these are 10G, two 10Gs are not going to give you 20G. That's going to give you something like 15G or something like that. So that is the overall understanding of port channel interfaces. The other thing about port channel interfaces is the logical interface, which is being created based on these physical interfaces, is going to inherit their configuration. And then whatever extra configuration that we want to have, we can configure on this port channel. That is very important to understand. This means that both of these links, or whatever the number of the links are, can be either routed links or, let's say, switch port links. They cannot be a combination of routed links and switch port links. So this is going to be either a port channel in layer 2 or a port channel in layer 3, which is very important to understand. Now, there is another thing that you should know. What we have created here is an independent port channel on each one of these switches. These switches, of course, are going to negotiate with each other about how to create a port channel, but whatever the configuration is local to the switches. So the number for the port channel, it doesn't really matter what it is. You can create port channel number 1 on switch 1 and port channel number 25 on switch 2. As long as the same links are being bundled, everything is going to be okay, and there is no problem in that. Now, there is another type of port channel which I'm going to speak about. Let me just show you. First of all, I want to delete this stuff here and then draw another thing for you. So let's say that I'm going to select these and just delete them. And going back to my black pen, I have, let's say, another switch down here. Let's say switch 3. Switch 3 is connected to switch 1 and switch 2. And let's say that, for example, switch 1 is in distribution or aggregation layer and switch 3 is in access layer. Now, switch 3 ideally has a link to each one of these two. In case one of them goes down, the other one is going to take over, and we can do much better. You know that in this case, a spanning tree is going to disable one of the links for a series of VLAN. In case, for example, you have configured MSTP, that series of VLANs cannot use both of the links. One of them is going to be blocked for each one of those instances. In case you have a common spanning tree, again, the root switch is going to determine which one of these ports is going to be enabled for that specific VLAN that we have configured. Here, what I'm going to do is to make sure that both of these links could be used to send information to switch 1 and switch 2 at the same time. So there is a concept which is called multi-chassis lag, or MLAG. In this case, what I'm going to do is to make sure that these two are going to look as if they are as one switch. And switch 3 is connected to one giant switch here. Let's say, for example, I'm going to say the domain ID for this is number 12, let's say. And switch 3 is connected to something like a switch 12. It doesn't understand that there are two switches up there. What is happening is switch 3 is going to bundle these two links, and it's going to get a port channel. But from switch 1 and switch 2's point of view, we have a multi-chassis lag or link aggregation. Switch 3 doesn't understand this. For switch 3, this is a normal lag or link aggregation. But switch 1 and switch 2 have to talk to each other, and they need to determine some specific things. For example, they need to kind of synchronize the information that they receive from switch 3. In this case, we are going to have something that in some other platforms they call it, let's say, virtual port channel, or MLAG in my case, in OcNOS, of course. And we can configure this to just get the best of both worlds and have link aggregation in here. So you see that we have two types of lag that we are going to talk about here, but of course there are more, and we can talk about them as well. The other thing that I'm going to configure in the next video, this video I have spoken enough, I guess, is, let's say, the amount of bandwidth that we have here. Let's say that, for example, this link is 20 gigabit per second, this link is 10 gigabit per second. I can just make sure that the link that has higher bandwidth is going to receive more flows than the link that has lower bandwidth. This means that for each 2 flow that I send on this high bandwidth link, I'm going to send 1 flow on this low bandwidth link. This means that I am configuring a weight for each one of these links. So the better link, the higher speed link, the higher bandwidth link is going to receive a higher weight. Let's say I'm going to configure as 20. This one is going to receive lower weight. Let's say, for example, I'm configuring this as 10. And based on that, the control plane is going to understand how to utilize these links inside link aggregation. So that's a very simple overview of link aggregation. What we are going to use for link aggregation, of course, like I said, is going to be the standard link aggregation, which is LACP, link aggregation control protocol. And also we can just go with static lag. Static lag has better troubleshooting, easier troubleshooting. But of course you have to make sure that the configuration is okay. Dynamic lag says that in case there is a switch on the other side that is willing to create this kind of a lag link, then we are going to go ahead and create that link. Otherwise, the links are going to stay in individual port modes. So let's go to configuration in the next video.